Okay, so we're going to talk about discrete and continuous variables now. Again, a discrete variable is just simply, just so you get an idea, discrete means that you have a specific value for it, all right? Something like flipping a coin. When you flip a coin, you either get heads or tails, all right? So you're getting a specific outcome, 1 or 2 or 3, a specific number. Continuous means that we have multiple, a range, basically, a range of outputs. So it could be like something between 5 and 10. For example, discrete, like I said, is flipping a heads or tails, so it's either heads or tails, so you have a specific outcome. And a continuous variable, it is going to be something like the number of parking spaces available at Bahrain Polytechnic at a specific day. It will be different from day to day. It ranges. So the number can be 200 one day, it could be 5 the other day, it could be 7, and it depends on time or it depends on something else. So the actual outcome of it will change depending on time. Discrete, usually they would form a table and you would be able to solve it easily, where here they will give you your X value and here they will give you your probability values, all right? So for example, heads or tails, so you're going to have 0 and 1, all right? And if you're flipping twice, 2, and I will explain this in a bit, and you will say the probability of each is a specific probability, so this is half, this is, I think, 1/4, and this is half again, or 1/4 again. All right, so it's going to be a specific number of probability, and I will explain this in detail in a bit, but this is how it would look like. I just want you guys to see how it would look like. So you'll have your X, the number of your outcomes, the successful outcome that you're looking for, and you'll have them in a specific number. For continuous, it is going to be in a graph. Most of the time, it will be in a way of a graph. So you will be having this type of graph, whatever type of graph, and for example, here, so let's say this is the available parking, all right, and time of day, all right, for Bahrain Polytechnic. So in the morning, Bahrain Polytechnic, at 8, it starts at 0, okay? So this is, let's say it's at 4 a.m., all right? You have almost no one in the parking spot. So you could say there's 0 people in parking. And then at 8, it goes up slowly, and a lot of people are coming. And then at 10, it peaks up again. And then at 12 p.m., it goes back down. And then it goes back up again for 2, and then it slowly goes back down. So this is what is meant by a continuous function. So, or a continuous variable. So the number is always changing, and you will always be selecting a specific range to look at when you are doing your analysis or you're finding your probability. So for example, you want to say the probability between 8 a.m. and 12 p.m. of finding parking. It is going to be the area under this graph, which we will look at also in a little bit, all right? So this is the main difference between continuous and discrete. It's better if I just start solving examples so you guys will get a bit bigger picture. First, we're going to talk about discrete, okay? So I'm going to use this as an example, and I'm going to be explaining it fully, what this table exactly means, all right? So the question just simply says, determine whether the following is a valid probability distribution or not and explain your answer. So we are given this format, large X is equal to small x. What does this mean? This basically means that this X is your unknown variable. Yani you don't know what the value is exactly, all right? Your unknown variable, which is a discrete variable, your unknown discrete variable. And this small x is the actual value. So it is a known value. Meaning this 0, this is a small x. This is a value we know. This 1 is a small x, a value we know. All right, same thing here. This 2 is an x, a value we know. And here, this capital P, this is the probability. So capital P of x equal to small x is simply the probability of this happening, of this occurring. So when it is capital, all right, or uppercase, this is again unknown probability. All right. The way you will write it, the notation of it, is you will write small p of small x. This is the same meaning. This is equal to each other because here we are defining the probability of the unknown variable when the unknown variable is equal to a known variable. All right, this is just notation, don't get too confused by it. So when you write it in small p of x, meaning you already know what the value of x is, so you can find the probability. So all of these values here, these are your small p of x, the actual probability of this occurring. All right, so this is your event 0, 1, 2, and this is the probability of that event occurring. This is all that this means. All right, so the question says if this is a valid probability or not. Why does it ask that? So if I just look at this part specifically, just the table now. Okay, I want to look at this table right now. So again, the top part is all the number of outcomes, of possible outcomes that you will have, and the bottom one is the probability of that outcome occurring. And then, so let's say for example, let's call this, we don't know what the capital X is, but let's say for example, this is talking about tossing a coin. And 0 heads, and like the probability here they're talking about is, for example, this is getting 0 number of heads. This is getting 1 number of heads. And this is getting 2 heads. All right? For example, this is just an example, because the probability would be different when you're flipping a coin. But this is just what this means, that there is an event that is occurring with this, with a separate, with a specific activity or event that is occurring. So this is all your possible outcomes, all right? So the probability, the total probability, when you sum this up, when I'm using this symbol, sigma, this is capital sigma in Greek notation, this basically just means sum. In other words, you're just adding up. All right? This is all that that means. So when you see me writing this sign, don't get scared of it. Don't go like, what is this? What is, I don't know calculus or whatever. Don't confuse yourself. This is all this symbol means is you're adding up everything. That's all that means. So when I'm doing the sum of all of this, when I'm adding all of these up, it has to always be equal to 1. If it's not equal to 1, then there's something wrong with my probability, because this is all the possible cases that I have. Or the probability of all of them happening is 1. Yani at least one of them is definitely going to happen. You cannot have it be a bit larger, or you cannot have it be smaller, because it doesn't make sense that your outcome is not definitely going to happen choosing one of these. Yani for example, let's say flipping a coin. If you flip a coin, you have to either get heads or tails. So if we use that as an example, if I just draw the table very quickly, we're flipping one coin. All right, we're flipping a coin. Flipping a coin. So we're either going to get heads, our sample space is either heads or tails. All right, we have to either get heads or tails when we flip a coin. We can't get any other value. So we will say that our large X is going to be when we get the event of getting heads. All right. So how many times we can either get heads, which is 0, which is 1. We can either get heads 1 time, or we can get no heads, which is getting it 0 times. So this would be my X equal X. Now these values, these are my small x's. These are my actual outcomes. These are my known values. All right. And now we're going to be talking about the probability of X, of this unknown, of getting heads is equal to either 0 or 1, of getting it or not getting it. Okay. So we know, from our previous sessions, the probability of getting heads and tails of flipping a coin is going to be 1/2 of getting heads, or 1/2 of getting tails. So if we're not getting heads, we're getting tails, which is half, and getting heads is also half. So you notice now the bottom portion here, when you add them up, you have to get 1. So half plus half is equal to 1. This should always be the case, because when you're flipping a coin, you're either going to get heads or you're not going to get heads, which is also known as tails. All right? This is basically what this means. So going back to this example, we know that this probability, we have to add them all up, and it has to be equal to 1. So when you do it in this case here, when you add these all up, so 0.2 plus 0.65 plus 0.15, the sum of them is going to be equal to 1. So this is a correct probability, discrete probability table. So it is a valid probability distribution, all right, for part A. Let's look at the same question. Let's look at part B. So for part B, you instantly can say this is an invalid probability. Why? Even if you add up all of these, if you add them up, yes, you will get 1. If you're just summing them all up, you're adding them all up, you will get 1. But we cannot have a negative probability. There is no chance of something happening in the negative. It either happens or it doesn't. We cannot say it is happening in reverse. That doesn't exist in probability. So instantly when you see a negative, just know that this is all incorrect because of the negative value. All right, so there's no negative probability. All right, so this is wrong because of that. And now let's look at the final example here. So again, here we have a random event, 2, 3, 4, 5, 6. We have 0 0.4, 0 0.15, 0 0.1, 0 0.02, and 0 0.35. When you add all of these up, so we are trying to find the sum of this. So we're just adding this plus this, plus this, plus this. If you take out your calculator and you add them all up, 0.2 plus 0 0.35, we will get a number of 1.01. This is not equal to 1. Therefore, this is also not a correct probability, not a valid probability, because our probability is more than 1. All right? This is the basic concept when it comes to discrete variables. But now let us actually start calculating the probability of specific events. So this is just the basic understanding. Here, this is just mentioning how you would create a table. I'm not going to go through that. I'm going to go through actually solving the table because that is the more difficult part. All right. So when we have a discrete random variable, x that has a probability distribution as shown below. So this table, this is our probability distribution over here. All right, this table. It is asking part A is asking us to find the value of k. If you notice here, it is giving us the letter k here and the letter k here. It's not giving us the final probability. So how will we be able to find this? Remember that when you sum this all up, it has to be equal to 1. So for part A, what are we going to do? We're just going to add everything and equate it to 1. So 0 0.03 plus 2 times k plus 2 times k, all right, plus 0 0.32 plus k is plus 0 0.05 is equal to 1. Because this is a valid probability, so it has to all be equal to 1. And now all you have to do is just simplify and solve for k. How do you do that? You're just going to add these terms together, the ones that are without k. You're going to add them up together. And the ones with the k, you're going to add together. So the k values, you're going to add together. Okay? So this will give us, so 0 0.03 plus 0 0.32 plus 0 0.05 is equal to 0 0.4 plus 2k plus 1k is 3k is equal to 1. And now we just solve for k. So the first thing we do is we take this 0.4 to the other side. Since it is positive over here, this is going to become negative on the other side. So it will be 1 minus 0.4. This is 3k. All right, just some basic algebra from Math 1. So 3k is going to be equal to 1 minus 0.4, which is 0.6. Then you're going to divide 3 both sides. And this will give us k, which is equal to 0.6 divided by 3, which is equal to 0.2. All right? This is how you will find your k value. You just equate all of these to 1 because the sum of all the probabilities has to be 1, and then you will solve for k. Now that we have found k to be 0.2, we can rewrite this table with the actual probability that we have found. So this is here, this part is 2 times k. So instead, we can just say this is 2 times 0.2, which is equal to 0.4. So now this part over here has become 0.4. All right? Same thing here. Here we have k, and we know that k is equal to 0.2. So this is now our new probability table. We have 0.03 for 0 and 0.4 for 1, 0.32 for 2, 0.2 for 3, and 0.05 for 4. Okay, now we have all our probabilities. Let's look at the next question. The next question says find the probability that the event x is greater than 2. So they want us to find the probability of our event x is greater than 2. What does this mean? We are going to look at our x value. Our x values is the top row. All right. We want it when it's greater than 2. So 0 is not greater than 2. All right. This is not greater than 2. This is not greater than 2. 2 is not greater than 2. Remember, if it's greater than or equals to, then it will be equal to. But here it's just as greater. So 2 is not greater than 2. So we will be looking only at these values over here. Okay. The probability values of this. This basically means this is going to be the probability of when x is equal to the values that are greater than 2, which is 3, plus the probability of when x is equal to 4. Why? Because we have 3 and 4, which are greater than 2, and we need to find their probabilities to find the answer. So probability when x is equal to 3 is here. It is k, which is 0.2. So this is equal to 0.2 plus the probability when x is equal to 4 is 0.05. So this is 0.05. So this will be equal to 0.25. All right? So this is how you would find the probability of a range. Or when it is greater than 2, when it's less than 2, whatever, this is how you'll do it. What if we have a specific range when it's greater than and less than? So like part C, it says 0 less than x less than or equal to 3. Again, you will do the same exact method that we did here. So I'm just going to copy paste this table down here again. Remember, this is 0.4 and this is 0.2, okay, which we found from early on. So the question was 0 less than x less than or equal to 3. So part C, P, the probability when 0 is less than x, less than or equal to 3. How can we look at this? Again, same thing. We will see where x is laying between. So it's greater than 0. So we know 0 is not a part of it because it's not greater than or equal to 0. It's greater than 0. 1 is greater than 0 and less than or equal to 3. So 1 is a part of it. 2, again, is greater than 0 and less than or equal to 3. So 2 is a part of it. 3 is less than or equal to 3. So yes, 3 is a part of it. 4 is greater, so it's not 4. So we're going to be looking at these values now. All right. So we're looking at the probabilities. So this is basically the probability of when x is equal to 1 plus the probability of when x is equal to 2 plus the probability of when x is equal to 3. All right, because these are the values that are within our range. When x is equal to 1, it is between 0 and 3. When x is equal to 2, it is less than or between 0 and 3. And when x is equal to 3, again, 3 is less than or equal to 3. So this is within our range. And we just put in the probabilities now. So probability when x is equal to 1 is 0.4. The bottom of the table now, the probability, plus the probability of 2 is 0.32. And the probability of 3 is plus 0.2. We sum this all up, we get 0.92 as our probability, or we can say 92% chance. All right? Same thing. And now part D. Part D says the probability of when x is greater than 4. Remember, our x value is at the top here. All right, let me just copy paste this one more time. We do not have a the x event will never happen more than 4. 4 is our last value. There is no x greater than 4. X greater than 4 does not exist. Doesn't exist. Therefore, this probability is simply going to be 0 because it doesn't exist. It will never happen, in other words. It's not possible for it to happen as it does not exist within our discrete variables. And then we do not have an x that is greater than 4. All right? Is this clear? This is how the basic discrete probability solving will be. Now let's look at another question. We will solve again the same idea. But here I'm going to be introducing a few new rules. All right. So this is the question now. The probability distribution for the random variable x is given below. So we have this probability distribution over here. All right. I'm going to copy paste it down here so we can use it later. So it wants us to calculate p when x is equal to 24. All right. So when x is equal to 24, where is that? It is this part over here. This is when x is equal to 24. So very simply, p of when x is equal to 24 is equal to 0.42. Very simple for part A. Now let's look at part B. Part B says when p of x is greater than 18. All right? This is what part B is saying. So again, we're going to look at the same table. We're going to look at the values that are over here. When is x greater than 18? Not 13, no. 13 is not greater than 18. 18 is not greater than 18. It is equal to it. And there's no greater than or equal sign. It's just greater than. 20 is, and 24 is. So again, we're just going to look at these values. All right. And now we can calculate the probability. So it's the probability of when x, or capital X, is equal to 20 plus when the probability of x is equal to 24. All right. So this basically means it is equal to 0.36 for 20 plus 0.42 for 24. So it is equal to 0.762, 78. All right, 0.78 or 78%. This is our chance or probability of this occurring, of this x is greater than or equal to greater than 18. Okay. Moving on to the next question. The next question says, let me just copy paste the table. The next question is saying that find the probability when x is less than or equal to 20. Now, there's two ways we can do this. Okay. I just want to remind you guys, remember, one rule that we used to use is this rule where we can say that the probability of A is equal to the probability 1 minus the probability of not A or A not. All right? Whatever is not A, basically. Remember this probability because it can be helpful in some cases. And I will use this in this example here. So in other words, if we want to find, so if we're saying x is less than or equal to 20, all right? What is not x equal to, or x prime in this case? It is equal to x being greater than 20. صح ولا لا؟ لأن the things that we have, the values that we have for x less than or equal to 20, if we're looking at the subset, all right, if we're looking at the set, it is 1, 2, 3, 4, 5, all the way up to 20. All right, and minus 1 as well, and all the way to negative infinity. If we're looking at this set, it starts from 21, not from 20, because it's not equal to 20. So it's 21, 22, 23, all the way to infinity. All right, so this function here, this is very important. To find the not of something, this is not, this is going to be the opposite of this, or the inverse, or the not function of this. So again, this we're talking about the probability. So the probability of this and the probability of that. So when we're doing it in probability, remember x greater than 20 is simply just not A. So what we can say is the P of x less than or equal to 20 is equal to 1 minus the probability of x being greater than 20. So again, the rule is when you have greater than or equal to for any number, all right? So when we say, for example, x less than 5, opposite of this, the opposite of this, all right, or the not will be x greater than or equal to 5. So if there is no equal sign, you will add an equal sign. If there is an equal sign, let's say greater than or equal to 7, the opposite of this, or the not, is going to be x less than 7. So if there is an equal sign, you will remove it and you will flip the sign. If there isn't an equal sign, you will add it, and again, you will flip the sign. All right? This is how you will just find the knot of any function in general. I'm just going to keep this on the side here. So when we want to find probability, this is how we do it with the knot. Remember, probability of an event occurring is equal to 1 minus the probability of the event not occurring. All right? This is what this basically means. So we can do it this way. Now, why did I choose to do it this way? If we look at this table, all right? If we look at this table, and let me bring this down here again. If we look at x is less than or equal to 20, we're going to have to find the probability of 13, probability of 18, and the probability of 20, but not 24, right? This is in the case of this. All right? So we're going to be finding these probabilities, 13, 18, and 20. Okay? So there are three values, and we're going to have to add all three values. In this case, it's simple. You could just do that. There's nothing wrong with it. Okay? However, there's a simpler way of doing it when you're using your not function. I'm teaching this concept here because you're going to be using this a lot as well in binomial and in normal distribution later. So when you're not doing it, it basically means x is just greater than 20. Where is x greater than 20? It is only the 24. So you only have to look at this. That's it. So when you have this part, this is only for the 24. So this is going to be equal to 1 minus p of 24. P of x equal 24. So in other words, it's equal to 1 minus 0.42, which is equal to 0.58. All right, let's check this formula. Let's check this formula. If we are going to do this directly, what are we going to have to do? We're going to have to add up all of these, right? So if we're just doing the orange part, we're going to have to add up all of these. So this has to be equal to the same thing, right? This on the left side, it has to be equal to the same thing. So if we're going to do it on the left, 0.10, so it's 0.10 plus 0.12 plus 0.36, which is the probability of x equal, what was it, 13? Plus the probability of x equal 18, plus the probability of x equal 20. All right? I'm just showing this to show you guys how they are going to be the same. You shouldn't be doing both. You should only be doing one of these. And if you see that there's a lot of values, try to do the not function to get less values. All right? But again, both methods are correct. So 0.10 plus 0.12 plus 0.36 is equal to 0.58. All right? You will get the exact same answer. Is this point clear, what I did here? Anyone has any questions so far before I go into the deep mean and the standard deviation of this? Is this clear so far? Okay, now let us move on. So again, we have this exact same probability or probability distribution. This is what they call a distribution, a discrete variable distribution. So now I am gonna extend this table a little bit. I'm gonna make it a bit larger, right? And I will show you why. Okay. So now the questions are asking us to find the mean. And before I extend this table, the questions are asking us to find something called mean and the standard deviation. All right. Standard deviation. And there's something we also have called variance. Okay. So we have the mean, the variance, and we have our standard deviation. Okay. So standard deviation, the symbol of it is usually just sigma, all right, small sigma. The variance is the same sigma, but squared. All right, so they're the same thing. So you can notice that standard deviation is simply equal to the square root of variance, or variance is just standard deviation squared. And then you have the mean, which is your mu. All right, this is the symbols that are usually used for it. So what is your mean going to be equal to? Your mean is equal to the sum, okay, of all your x's, All right, the sum of all your x's, your x, the small x's, times the probability of those x's happening. The sum of all of them. So you'll basically do 13 times 0.10 plus 18 times 0.12 plus 20 times 0.36 plus 24. And we will do this for this example now. The variance is equal to, again, it's equal to the sum, all right? It's equal to the sum of e of x squared, which I will talk about in a little bit, all right, minus mu squared. Again, this mu is just our minus mu squared. This mu is just our mean. So it's the mean squared. So once we find our mean, we can find our mean squared. It's fine. But what is this ex squared? So the mean itself is sometimes written as e of x. Okay? This is a different notation of writing the mean. So the mean mu is also equal to e of x. So e of x squared will be equal to e of x squared will be equal to, let me change the color of this to orange. So e of x squared, where e of x squared is equal to the same thing as the mean. So e of x is equal to the summation of x times p of x. E of x squared is going to be equal to the summation of x squared times p of x. That's all that that's all that this means, ex squared. And we will see it in forms of table. It will simplify all of this. I will show you how to just resolve it all. But this is what the equation for it is. So e of x squared, the summation of e of x squared, so all of these, all right? So we're going to be squaring the x's and then multiplying it by the probabilities, minus the average that we have already calculated, or the mean that we have calculated from the first equation. And sigma, or standard deviation, is the easiest one because it's just equal to the square root of the variance that we get. All right, that is all you have to do for standard deviation. So now, how do we do this in a way that it will not be too complicated? We are going to create a table. All right, so I'm just going to work off the same table that we have here. We are going to be creating a table. And we're going to be adding a few things more to this table. So I'm just going to be extending this table a bit more. All right. And this is how I would recommend you guys would solve always in the exam. Okay. So we have our x, we have our p of x. This x and p of x, remember, this is the same as just saying, this is your x. All right. Actually, let me just keep these in black. This is your x, and this is your small p of x. All right. The same thing. Okay, this is the same thing. This is just the way they do the notation, all right? So we could think of this as these are your x values, and these are the probability of your x values, because these are all known values. Now, so there's one added thing here that I'm going to show as well. Let me just finish making my table. So the way you're going to do it is you're going to split your table the same way it is split there, okay? You're going to have the same split as the one above. First thing we need to find is average, mean, which is mu. Okay, we're gonna need to find it. How can we find mean? What is the mean equal to? So mu is just equal to sigma of what? It is x times p of x. All right. So what are we gonna do here? We are gonna just multiply x and p of x for every value here. So we're gonna do 13 times 0.1, 18 times 0.12, 20 times 0.36, and 24 times 0.42. That's what this means. So I just multiplied x by p of x for each and every one. If we get the answers for each, this was 1.3, this is 2.16, this is 7.2, and this is 10.08. All right. So to find the mean, remember that to find the mean, we need the sigma. Basically means we need to add every single one of these values now to each other so that we can find the mean. So we'll find that our mean here, I'm going to put it at the end here. because it's just the sigma after adding all these values. So we're going to add 1.3. So we're going to add this value plus this, plus this, plus this. All right? This is what we're going to be doing. We're adding all of these values together. So 1.3 plus 2.16 plus 7.2 plus 10.08. This is going to be 20.74. And this is your mean. All right? Usually how I would draw this is I would write my sigma up here. I will just write, and I'll add an extra table slot. I'll write sigma. All right. And I know that the first one, when you add all of these up, all right, it has to give me 1. All right. So this is just for the probability. For the mean, mu, when we add all of these up, we get the value of the mean. So this is our mean value now, 20.74. We have found our mu. So mu is equal to 20.74. All right. We have found our mu value. And now let's look at our next value. So the next value I usually put here, we need to calculate variance, right? And for variance, we need to first find x squared. So I'm going to put this here. We need to find x squared. X squared. This is the next thing we're going to do. What's x squared? We just simply square everything that we have. So 13 squared, 18 squared, all right, 20 squared, and 24 squared. This is what you will be doing. All right. Obviously, in the actual number you're only going to leave here is the answer. I'm just solving it here so I can show you guys what I am doing. But what you guys are going to do is you're just going to put 1.3. You're going to put this in the calculator as 1.3. Put this in the calculator and then just write 2.16 in your box. Then 7.2. Then 10.008. Same thing here. I'm writing 13 squared just to show you that what I'm going to be doing. But what you're going to be doing is putting 13 squared into the calculator and then writing 169 in your box. 18 squared, you're going to put that in the calculator, which is 324. 20 squared, which is 400. And 24 squared, which is 576. All right. The next step is now to find our e of x squared. So remember, this is mu. This was our mu. Or sometimes this is also named as e of x, all right, which is equal to this. This is also known as mu. It's the same thing, okay? It's just different ways of writing this equation. So now we are trying to find our e of x squared, okay? Sorry, e of x squared, squared is inside. E of x squared. In other words, we are going to be applying the same formula that we have applied up there, which is sigma. But now, instead of x, we are finding x squared times the probability of x. So we're going to be multiplying, for the orange part, we're going to be multiplying this value with this value. All right? And this value with this value. And this value with this value. And this value with this value. All right? Because this is our p of x, and this is our x squared. So what does this mean? We're going to do 169 times 0.10. 324 times 0.12. 400 times 0.36 and 0.42 or 576 times 0.42. You will find the answers for each one. Again, I'm only doing this here so I can show you the step that I'm doing, but all you're going to be doing is actually just writing the solution or the value, the answer, 144 and 241.97. Okay? So this is how you will fill out your table, and that's it, what you need for your table. But remember here, we have summation. So we need to sum up this entire box at the end. Okay, so we're going to need to sum this box up. That means we're just going to add this, this, and this together, this value with this value with this value with this value. All right, and it's going to be equal to, again here, this is equal to, not plus, this is equal to. What is it equal to? So 16.9 plus 38.8 plus 144 plus 241.92 is going to give us 441.7. So now we have found our e x squared value. We found this to be 441.7. Okay? This is the steps you will always follow when you're trying to solve. Again, just to repeat, the reason we're doing this is we're trying to find our mean, our variance, and once we find our variance, we can find our standard deviation from that. All right. So what we are doing is the mean, the equation for it is just x times the probability. Then after finding our mean, we're going to add them up to find the mean. Then we're going to do x squared, so we can find our e of x squared, and then we're going to add them up. All right. This is how we are going to do it. Now we found our mean. We know that our mu is equal to 20.74. This is the mean. But remember, for variance, what else do we need? Variance is equal to, or sigma squared, is equal to e of x squared minus minus mu squared. So we also have to calculate mu squared. So to find mu squared, you just simply square mu. So it's going to be 20.74 squared, which is equal to 20.74 squared, 430.1476. All right, very important. We have to square our mu so we can solve for variance. All right, don't just put in the mean value, you have to square it. So our variance is now going to be equal to e of x, we have found it, e of x squared is 441.7. So 441.7 minus, what is mu squared? 430.1476. All right, so our variance is equal to, our variance, which is sigma squared, is simply just equal to 441.7 minus 430.1476. We're going to get 11.5524. All right, this is our variance. Now to find our standard deviation, so standard deviation, this is going to be equal to the square root of variance. That's it. All right, because it is given as sigma, so it's equal to the square root of sigma squared. All right, this is basically what it is. It's the square root of sigma squared. Okay, which is usually what we name our variance. So our sigma is simply going to be equal to square root of 11.5524, which is equal to square root of this is 3.39888. All right. If you notice here, this is how we found our standard deviation. This is how we found our variance. We have found our mean. If we go back to the question at the very beginning, it was asking for us to find the mean, or e of x, the expected value of x. This is another wording, another naming for the mean, and the standard deviation, or the square root of the variance. All right. If you notice here, the solution is incorrect in the sheet. All right. Okay, I double checked this like 10 times to make sure. This is incorrect. The actual answer is 3. How much did we get? 3.40 تقريبا, يعني if rounded up. All right, 3.40. Okay, any questions about this? Because this is the last part I will be doing about discrete variables. Everything else is straightforward and should be easy to solve. So is this clear? Moving on. Let's do the examples that are given now for a continuous variable. A continuous variable will always be given in the terms of a graph, okay? It cannot be given in terms of this because this is only for discrete value. Like I said, a continuous variable is always changing. So let's take this for example, and let's solve it very quickly. Okay. So for a continuous random function, random variable, sorry, x, find the area of the shaded unshaded area. Again, this is very easy. All you have to do is basic geometry here. All right. So to find this area, this purple area, you have to look at the base of this triangle. Remember, this is a triangle, so you're going to have to look at this base. Base is equal to 1. All right, the distance from 0 to 1 is just 1. And the distance from 0, the height, this is our height h. The distance from 0 all the way to 2 is equal to 2. So we just apply half base times height, the area of a triangle, which is equal to half. The base is 1, height is 1, height is 2, all right? So it is equal to 2 and 2 will cancel, it's just equal to 1. So this is your answer, the probability, which is 1, which is also equal to the area of this triangle, All right? It is very simple. You just have to remember your shapes, the basic shapes and your basic areas of a shape from Math 1. Yeah, and let's go and do one more, which is this one. I will not cover this because we're going to cover this in normal distribution later. So let's just do this, the trapezoid, very quickly, just so you guys have an idea for another continuous function, how it might come. The way you will solve this, because I know most of you have forgotten your very basic geometry, the way you will solve this is you're going to cut this into half, all right? And you're going to have shape 1 over here, and this is your shape 2, right? So you have a rectangle at the bottom, and you have a triangle at the top, because I know most of you will not remember the trapezium area formula. So this is the easiest way to do it in my opinion. So we need to find the area of both. So the trick here is to know how to know your dimensions, your sizes. So here it says 1. So this has to be 0.5. Okay, this distance over here. Here it's from 1 to 2. Okay, so if I just draw this square part or rectangular part at the bottom, the rectangular part is going to look like this. All right. It starts from 1 to 2. So how are we going to find the total? The total is going to be 2 minus 1, the distance of it, because this is not 2 minus 0. No, it's not starting from 0, it's starting from 1. So we do 2 minus 1, it is equal to 1. So this is our first dimension. So this is 1, the base of this rectangle. The height, it goes from 0 to 0.5. So it's 0.5 minus 0, which is just 0.5. All right, this is the height of this rectangle. So we can find the area of this rectangle very easily now, base times height. So the area 2 is equal to 0.5 times 1, which is just 0.5 meters squared, but there is no meter squared here. It's not any specific dimension. We're talking about probability. All right. So let us look at the triangular part now. Okay. The triangular part is let me just draw it again. The triangular part looks like this. Okay. Almost like that. This is just connected here. Okay. This is what the triangular part looks like. And here, again, we know that this point is 0.5. If we trace this point, we're going to notice that if this is 0.5, this is 1, this is 1.5. All right. Again, make sure you know how to find out your values. So the triangle's height is starting from 0.5 up to 1.5. So the height is equal to 1.5 minus 0.5, which is 1. All right. Again, it is starting from 0.5 and ending at 1.5. It's not starting from 0. So it's not just 1.5. It's going to be 1.5 minus 0.5, which is 1. So we have found our height to be 1 over here. And the base of it is equal to the rectangle's width, which is 1 as well. So now, if we're trying to find the area of this is area 1. We're going to use half base times height. Let me put this on this side. So half area 1 is equal to half base times height, which is equal to half 1 times 1, which is equal to 0.5. Okay. So how are we going to find now the value? We're just going to add area 1, total area. All right. Area total is going to be equal to area 1 plus area 2, which is just equal to 0.5 plus 0.5, which is equal to 1. And that's it. Remember, your values have to be between 0 and 1. They can be 1, they can be 0, that's fine. But your values have to be between 0 and 1 because we are finding the probability, and the probability is found by finding the area under the curve. All right. But again, your areas have to always be 1 or less, يعني between 0 and 1. Okay. And that's it for week 5, all of it. Any questions before we move on to binomial? Nothing? All right. Let us move on to binomial. So this is now week 6 material. All right. Week 6. All right. Let's take just a 2-minute, 3-minute break, and then it's 4:59, and it's almost 5. 5:03 we will start again. All right. 5:03. We'll be back at 5:03. Just I want to go get me some water and I'll be back. تمام. Okay. So let us start with binomial distribution. What does binomial distribution mean? Binomial basically means it's either yes or no, or in other words, true or false, or it's just either happening or يعني occurring or not occurring. Okay? So it's basically either it's going to happen or it's not going to happen. Those are the only two probabilities that you're going to have of it happening or of it not happening, but it's a distribution. So you have it over a lot of different factors. The way they usually write this is they would write x, a random variable x, all right, has a binomial distribution, the letter b, of a number here, which is your n, which I will talk about in a bit, and a number here, which is your um, P, which is your probability of success, which I will talk about in a bit as well. So the important things you guys need to know here is this. You have the letter N. Your N is your sample or your total number of trials. All right, so your total number, let me color code these actually. All right, so your N is your total number of trials. All right, and you have your P, which is the probability of succeeding. All right, so the probability of getting a success of this. So we'll say success, probability of success. So the probability of the event occurring, yani. All right. And and what else? Yes, we also have Q. Q is simply just the probability of failing. Or in other words, it is not P. Okay? This is how I usually write it, not P. So what does this mean? It means that Q is equal to 1 minus P, and P is equal to 1 minus Q. All right? Because they're the opposite of each other's. So if it's not going to succeed, it's going to fail. If it's not going to fail, it's going to succeed. All right? So that's basically what it is. That's what Q is. All right? So if you want to find Q or if you want to find P, this is how you'll find it. Most of the time they will give you P and you will have to find out your Q. So your Q is going to be always just 1 minus P. Okay? And the last thing is going to be your X. All right? X, I'll keep it as black. Your X, which is equal to the total number, not total number, the number of successful trials. In other words, if an event happens 10 times, all right, and you say it will pass 6 times, all right, so this is the X value. So the number of successful trials is it worked out 6 times. That's what your X is. And we will see that clearly now in this example. And there is one formula you guys are going to need to know, all right, which is P of X. This is the probability of X occurring, of this success, is equal to, what was it equal to? Yes, it's equal to N. Sometimes it is written in this form, so I'm just going to write it also in this form. It's equal to Nx P to the power of X times Q to the power of N minus X. All right? So what does this mean? What does this bracket mean? All this means is this is the same as NCX. Remember our combination, NCX? This is what this basically means, this bracket. So it's NCX times the rest of this, which is P to the power of X times Q to the power of N minus X. So in other words, you can say that this is how you will find the probability of anything that is occurring, the number of times it is being successful, the P of X. Okay, once you are given the size of your sample, which is N, the total number of trials, and you are given the probability of it succeeding. Because remember, Q, you can find it out from just simply subtracting 1 minus P. So another way usually this is written is it will be Nx. Again, it's going to be just the same exact thing. All right, it's going to be Nx Q N minus X, but Q is just 1 minus P. So you can write it as 1 minus P. All right. It's exactly the same thing. I prefer using Q, so I don't mix up a lot with the formula. N minus X to the power of N minus X. All right, so this might be another way of using it. Me, I usually just use this equation because I understand what this equation means, and I just apply with this equation. And this is what you will be always using for all your binomial distributions. All right, so if we look at this example here, again, I'm just going to take this, and I'm going to take it everywhere I go. I'm going to use this everywhere I go now, because this is the formula that we will be using for everything, okay? But let us see how to use it now. So this question says a random variable x, b, 7, and 0.6. So 7 is our n. It also is mentioned down here. This is our n. And our probability is 0.6. Okay? This means that the variable x has a binomial distribution with n equals 7 and p equals 0.6. Determine the following. So A says find the p of x is equal to 5. All right? Again, all you are going to do is use this equation, p of x and x. So p of x equal 5 is equal to nx, which is n. What is our n? First of all, before even starting, let us determine all our values. So in this case, n is equal to 7, p is equal to 0.6, q is equal to 1 minus p, which is 1 minus 0.6, or in other words, it's just equal to 0.4. This is our q value. And now our x value, it is given in the probability. That's how it will always be. Our x is equal to 5. So we substitute this into the equation. So it's going to be 7 combination with x, which is 5, all right, times the probability p, which is 0.6, to the power of x, which is 5, times the probability of q, which is 0.4, to the power of n minus x, which is 7 minus 5. And that's it. You just apply this equation and you put this into your calculator and you will get your probability. So if I do this, you get a probability of 0.2613. All right. So this is the probability you get. So you put this all in your calculator and you will find this probability directly. This is how you will be applying for all your binomial functions. So for part B, it's going to be the exact same thing for x is equal to 7. But let's look at part C. It says E here, but this is part C. Let's look at part C. All right, which is this, part C. It says P of x less than 4, or less than or equal to 4. All this basically means is, if you remember from the probability when we were doing discrete variables, all this basically means is this is the probability of x equal 1 plus the probability of x is equal to 2 plus, actually we start with 0, and I'll tell you why now. The probability of x is equal to 0 plus the probability of x equal to 2 plus the probability of x is equal to 3 plus the probability of x is equal to 4. Okay, so 0, and there's 1 as well. So probability of x equals 0 plus the probability of x equal 1 plus the probability of x equal 2 equal 3 equal 4, because we're starting from 0 up to 4. What does this mean? When we have an x variable, all right, so our sample space in this example, n is equal to 7, right? So our x, the range, the total range of x is going to be between 0 and 7. The total number of success trials, remember, x is just the number of successful trials. It has to be less than or equal to the total number of trials. You cannot succeed more than having the number of trials. For example, if you flip a coin 10 times, you cannot see the success of flipping a coin 11 times because you're only flipping it 10 times. You want to see how many times you get heads? 10 times. You cannot see the probability of if you get heads 11 times because you only flipped it 10 times. This is the idea. So you can start with from 0, not flipping it at all the way up to the number of times you flipped it, which is 7. Okay, so in this case, it's x less than or equal to 4. So you're going to start from 0 all the way to 4. And this is what I want to show you. So we're going to start with p of x equal to 0. So we're going to have to apply this equation, the same equation that we're using here. We're going to have to apply it for each and every single one of these, which is equal to x is equal to 0. Remember, again, we have the same n's and q's. This does not change. These are the same values, they never change, our ends P and Q for the question. So for P equal to 0, let me just write this as 0.4. Q is equal to 0.4. So for P equal to X equals 0, we're going to do 7 C0 times 0.6 to the power of, just 1 second, to the power of X, which is in this case 0, times the probability of Q, which is 0.4 to the power of n minus X, which is 7 minus 0. All right? Sorry, 1 second. Okay. So this is what you're going to get. Remember that CZ, if you remember your combination very well, 7C0 is basically just 1. You could put it in the calculator and check, but it's 7C0. What does this mean? You have 7 and you're choosing 0 from it. All right? So you're just choosing 1 from it. All right? So the combination is only going to be, there's one choice only, because you have only 0 choices out of it as a whole. So it's going to be 1 times any number to the power of 0 is equal to 1 times 0.4 to the power of 7, which is equal to 0.4 to the power of 7 is 1.638 times 10 to the negative 3. When you get 10 to the negative 3 in a calculator, all this means is you are multiplying this number by 10 to the negative 3. Yani you are moving your decimal point over here. All right, you are moving your decimal point. That's it, 3 times. So it's going to be, this is the first time, and you're going to put zeros here. So it's equal to 0.001.638. That's what this means, okay? So don't get confused by that too much. Just keep it the way it is, 1.638 times 10 to the minus 3. Just keep it the way it is, okay? Basically, it means it's a very small probability. That's it. Okay, so we finished for X equals 0. We're going to be doing the same again for each and every one. So P of X equal 1, it is going to be 7C1 times 0.6 to the power of 1 times 0.4 to the power of 7 minus 1. And then you're going to be doing this again and again and again over and over again for each value of X. So the only thing that is changing is your value of X, all right? So you can do this manually, all right? It will take a lot of time. You can do this manually, but I want to show you guys a trick in the calculator. So X1, we have 1, 2, 3, 4. Okay, we're going from 1 to 4, and the X values here are all going to change. So it's going to be 2, 3, 4. And here again, the X values are all going to change. Okay, the first one was 1. This is power 2, power 3, power 4. And here it's minus 1, 2, 3, minus 1, minus 2, minus 3, and minus 4. Okay? It will take some time if you calculate each one by itself, but it won't take that much. But if you guys want a trick on your calculator, I would recommend that you guys pull out your calculator right now. All right? Using calculator. We will use something called mode 7. Mode 7, right? Which is table. Okay? So the first thing you will do is hit mode 7. All right? You're going to notice that on your screen, you're going to get something like this, f of x equal, right? Or it's capital X, f of x equal. Again, if you want to use the calculator to solve this all very quickly, this is one method to do so. And then you're going to write the same equation, all right? The same equation over here. But the difference is, so the values here, this is the equation we're writing, right? Which is 7c1 to the power of, so 7c1 times 0.61 times 0.4. But instead, any value of x, we're going to leave as x. So in this case here, this is x, x, and x. All right? This is how you will write your equation here in f of x. So with the calculator, you're going to hit 7 combination x. How do you hit x? To get your x value, you're going to hit alpha which is right next to shift at the top, plus the closed bracket sign. If you notice, on top of it, and here in red, it says x, right? So alpha, closed bracket sign, x, times 0.6 to the power of, again, alpha x, times 0.4, again, to the power of 7 minus x, okay? So this will be the first step. You will type this into the calculator in the same way I said it. And to get your x, it's just alpha with the closed parentheses sign. Once you hit equal, now you will be hitting equal, all right? So after that, you will hit equal sign, the equal sign, all right? So now you will click equal sign. You will notice that it says something like this, all right? So now after that step, you're going to hit your equal sign. It's going to say start question mark, all right? What does this mean? This means what is your starting value for x? Where are we starting for x here? We're starting from the value of 1. So we're going to just click 1, and usually in default it's 1. So we're just going to write 1 and equal. Okay, so we're going to hit 1 and equal. And now you're going to notice it says end. All right? When it says end, this basically means the last value you want for x. So in this case, it's value number 4. All right? So we're going to hit 4 plus the equal sign. So it's going to be 4 equal. And then it's going to just say step. In this case, leave the step the way it is. Do not touch it and just hit equal. And then you will notice you're going to get a table in this form. All right. And that's your final step. You're going to get a table in this form where you have your x value over here. All right. And you have your f of x value over here. So this will be the answer to each and one of them. So when x is equal to 1, I got 0.0172. All right. You can use your arrow keys on the calculator to move around that table. So right, left, up, and down. X is going to be 2. You're going to get 0.0774. And then you go down, you're going to get for 3, 0.1935. And then you're going to go down, and you're going to get for 4, 0.2903. Okay? This way, you're going to be able to find out the probability for each and every single one in a binomial distribution. I'm not going to repeat this method. I just said this one time so that if you guys want to use the calculator, but if this is too confusing, just use the normal way. Just put each number in the calculator, calculate each one by one. Okay. So this is it. So the solution for Px equal 1. So P of x equal 1 is equal to 0.0172. All right. P of x equal to is equal to 0.0774. These values are your P of x. So these values now, these are your values of P of x. All right. So again, Px of equal 3 is equal to 0.1935, and P of x equal 4, it is 0.2903. And these are all your values. Remember the original equation, what were we supposed to do? We're supposed to add up all of our P of x's. So we can find out our P of x less than or equal to 4. All right. So P of x less than or equal to 4 is P of 0. P of 0 we calculated manually earlier. We calculated it manually. You could have also put 0 in your calculator starting from there. You could have done that. That's completely fine. But I calculated it earlier. That's why I didn't put it there. So it's 1.638 times 10 to the minus 3. The way you'll write this is you'll just open brackets, 1.638 times 10 to the minus 3, close brackets, plus open brackets. Yani in the calculator, when you want to write this, just write it in this way and you will never have any mistake, okay? 0.0172 plus 0.0774 plus 0.1935 plus 0.2903. Now we go to our calculator again. to go back to your normal form in your calculator, when you're done, you just have to hit mod 1. All right? That's all you have to do to go back to your normal form. So mod 1 to go back to normal calculator. All right? So just mod plus 1. Mod 1, we go back to our calculator now, and we just calculate all of these. So 1.638 times 10 to the minus 3 plus 0.0172 plus 0.0774 plus 0.1935 plus 0.2903. We're going to get a value of 0.58. Okay? And that's how you would solve it for part C. Okay? You get a value of 0.58 for the probability of x less than or equal to 4. Is this clear what I did here? Not the calculator. The calculator, again, this, if you're comfortable with it, use it. If you're not, just apply these formulas in your calculator directly and solve. Remember, in statistics especially, the technique, the most important technique is knowing how to use your calculator more than even in engineering, because in statistics, you're always dealing with a lot of numbers and you're dealing with a lot of combinations and permutations. So trying to take advantage of your calculator is the best way to solve. But the concept, is it clear? Again, just a quick recap. We are trying to find x less than or equal to 4. X less than or equal to 4 means we have the range of x being from 0. All right. So this x is ranging from 0 to 7 because the total number of trials is 7. 0 is doing no trials, which is a possible, so no successful trials, and 7 being all of them successful trials. All right. So your x has to be between 0 and 7, which is your n. Okay. So x has to be between 0 and n. Okay? So yeah, so this is our x less than or equal to 4. What are values we have? We have from x0 to all the way up to x4. So 0, p of 1, x equal 1, p of x equal 2, p of x equal 3, p of x equal 4. So we're going to calculate each one using the binomial equation, which is here. And then we're going to add. Another method, if we're not using the binomial equation, because I'm not sure if the tables are going to be provided in the exam, but I want to show you guys how you will use the table as well, all right, for the same exact equation. So if I go bring up the table of binomials, this is this one, so n is equal to 7 here, so we're going to use this. This is the table of your binomial probability distribution, all right? If you notice, here, this is your probability P, the value is here. Let me make this a lot bigger at first. You fill it with the page as well, and we can see it clearly. All right. So the top here, this is our probability P, our small p, okay? Over here, we have our n, and over here, we have our x. So our small p in this question is equal to 0.6. 0.6, all right? Our n is equal to 7. So the method of using this table is, the first thing you're going to do is you're going to look at your p, your probability. So it's 0.6. So we know it is going to be somewhere between the two blue lines over here. All right. This is the first thing you're going to do. All right. So we know it's going to be somewhere between these two blue lines. Okay. We know the value of p is 0.6. So this is the first thing we determine, because here it says 0.6. Okay. That's the first thing. Now we're going to look at our n. When n is equal to 7, so here it says 2, 3, 4, 5, 6. This is 7. All right. So we're going to be looking at 7. So it's going to be somewhere between these values. Again, if you notice here, when you have an n, you have your x value. Your x value is 1 and 2 because your x value can be 0, 1, and 2. If you notice the very first row, there's nothing. This is 0. Very first row, there's nothing. It is basically a 0. Okay? So you have 0, 1, 2. When n is equal to 3, you're going to have from 0 to 3. When n is equal to 4, you're going to have from 0 to 4. When n is equal to 5, you're going to have 0 to 5. This is the values you have for x. So now we want to look at the values of x that we needed. What were the values of x? We needed the values of x from 0 all the way to 4. So we're going to look at the values of x from 0 all the way to 4 when n is equal to 7. So we are looking now at these values. All right, let me highlight them here. We're looking from 1 all the way to 4. We're going to be looking at all of these values. And we want to look at these values within the blue line. Okay? Over here. So let's start one by one. Let's start one by one. So P of x equals 0 is going to be equal to 0.0016. Okay? Remember earlier we found that 1.6 times 10 to the minus 3. It's the same thing. P of x is equal to 1. We're going to look at 1. So now when we're looking at 1, the value is going to be this, 0.0172. All right? P of 1x is equal to 2. Sorry, we didn't even do 2. 2. It's going to be the next one. 2. This is x equal 2. We have to have it in between these blue lines, so it's 0.0774. P of 1x equal to 3. Again, same idea. We're going to look at 3. Between the line, it's 0.1935. And the last thing is P when x is equal to 4. All right. Again, same idea. We're going to look at 4. This is 4. So it's 0.2903. If you notice, it's the same values we got earlier. So 172,774 earlier on, 172,774, 1935, 2903. So 1935, 2903. All right, same exact values that we are getting. If you have the table in the exam, I would recommend using the table to solve because it will save you a lot of time. As you see, we solved the question instantly with the table as long as you know how to use the table. If they specifically say using the binomial, but I believe your exam is multiple choice, so you guys can choose whichever method you want. Both methods can work. All right. I'll use the table to solve one more question before I go to standard. Not standard, the normal distribution. So let us do part E. Okay, part E. When P of 3 less than or equal to x less than 6. So part E says P when it's less than or equal to P of x when it's less than or equal to, what was the value? 3 less than or equal to x less than 6. Okay. The way we'll do this here is, so we have 3 less than or equal to x less than or equal to 6. What does this mean? We have P of 3. All right, small p of 3. I'm just going to write it that way because it will save some space. So small p of 3 plus small p of 4 plus small p of 5. And that's it, because we have from 3, 4, and 5. That's it. We are 6, there's no equal, so we're going to do that. Let's use the same table again, the exact same table. Let's use it to solve this. So now we are looking for, we have already found the p of 3 and p of 4 earlier. All right. So we have found these two values over here, which is 0.1935 and 0.2903. So now we can just find the p of 5. P of 5 is going to be this one over here, the 5, which is 0.2613. So P of x equal 5 is equal to 0.2613. And now we can just plug in all the numbers directly. All right. So 0.1935 plus 0.2903 plus 0.2613. And we're going to get 0.1935 plus 0.2903 plus 0.2613. Okay. So it's 0.7451. Tamam? This is how you will be using the table when solving, and the earlier method is how you're going to be using your binomial equation. All the remaining questions are very similar, all right? I wanted to do one word problem if I had time, but unfortunately I might not. But let's do one quick word problem. I'll just do one part of it, so you guys just get a better idea. It's fine if this session it will be extended a bit. It's fine. I'll make sure we complete everything before we move on. All right, before ending the session. So suppose that 10% of fire alarms in a city are false alarms, and let X denote the number of false alarms. So this is our successful event, which is having a false alarm. Okay, so remember P is our successful event, which is 10%. 10% in other words is equal to 0.1. Okay, because this is false alarms and this is also talking about false alarms. So our X is going to be the number of false alarms that is occurring, which is our successful event. Here it says in a random sample of 20 alarms. This is our N. The total sample size is 20 alarms. Once you get your N and your P, you can solve for P of any value. Okay. Here we're going to solve using table. So it says calculate the probabilities for the following number of false alarms. So the first one is P of 5 less than or equal to X less than or equal to 10. So we're going to go to our tables. All right. I'm going to solve this purely using tables. So we're going to go to the table where n is equal to 10. This has n equal to 10. Let's take this one. Okay, because, sorry, n equal to 20. Our n is equal to 20, so we have to go to the one with the n is equal to 20, which is, inshallah, mawjood. Yes, it's over here. All right. So n is equal to 20. Let's bring in the table. All right, this is our table. Okay. Okay, I think this is big enough. So let's look at our table. First thing, we need to determine our P. What is our P? It is equal to 0.1. So P equal 0.1. What is our N? Our N is equal to 20. Okay. So first we look at our P. Our P is 0.1 is over here. This is 0.1 over here. Okay. So we're going to draw our lines like this. Okay. For the values of 0.1 over here and over here. It's going to be between these two lines. Okay. For 20. If you notice one thing, the P of 10, 11, 12, 13, 14, 15, 16 is all not given. Why? It is because it is an extremely small number. It is super small. So you cannot even like calculate it. It's going to be like 0.0000005. So basically you can assume that they're just zero. All right. You can assume that any blank space is just a zero. All right. Because they're a very small probability. So this is the values we have. So what is the question? It's between 5 and 10. It's asking for 5 less than or equal to x less than or equal to 10. So what are the probabilities we need to find? We need to find the probabilities. I'm going to write them here. So P of x, actually, let's write it in the question itself. So this is equal to P of 5 because it is less than, greater than or equal to, plus P of 6, plus P of 7, plus P of 8, plus P of 9, plus P of 10. This is why you use a table for this question, because look at how many probabilities you have to find. So in this case, we're going to go start from 5 all the way to 10. So let's look at 5 first. 5 is over here. So we're going to be looking at all these values. So 5 up to 10. So 5 here is 0.319. 6 is 0.089. 7 is 0.020. 8 is 0.04. 9 is 0.001. And 10, since there is no value, we're just going to take it as 0. All right. Or you can apply the binomial formula, this formula that we used earlier on, this formula over here, and you will get an extremely small number for 10. Okay. So now we can just simply solve. We're just going to say that the P of x being between 5 and 10, this p is equal to 0.0319 plus 0.0089 plus 0.0020 plus 0.0004 plus 0.0001 plus 0 for P10, all right? Which is equal to, put this in the calculator, 0.0319 plus 0.0089 plus 0.0020 plus 0.0004 plus 0.0001 is going to be equal to 0.0433, which is equal to 4.33%. Okay? This is how you would solve any binomial distribution. Any questions about the binomial so far? Any questions about how to use the table? My recommendation is, if it is not explicitly wanting you guys to have to use this equation, I would just use the tables, as it makes life so much easier. Okay? يعني if you have access to the tables in the exam, make sure تاخذوا المسطرة وياكم, take a ruler with you to the exam, and use it to find all these probabilities, because the ruler is going to make it easier, so you can line it under each one and draw your lines and all of that and find it. Okay? Now we are remaining with our last point, which is normal distribution. Normal distribution. So normal distribution, unlike binomial, the normal distribution, it has a range of values somewhat like what you call it, the continuous variables. يعني عندكم a random range of a distribution, and most of the time it is going to be in this bell curve. This is your normal distribution. It is going to look like this. Okay, something like that. All right, this is your normal distribution. Okay, where this is the value of your probabilities to the left and right, this y-axis. Okay, this is your probability of x, and this is your x value. All right, so the probability of x occurring, and this is your x value. Tamam? Oh, one thing before actually I move on to normal distribution, just one quick question. It's just a formula that you apply. For binomial, you also have mean and you have standard deviation, right? So remember, this is your mean and standard deviation. Standard deviation. It is super easy. All you have to do is mean is equal to, I forgot the formula completely. It was Pn, yes, Pn. NP, N times P. Remember, this is your mu, all right, your mean, okay? This is mean, which is mu. And your standard deviation is equal to sigma, which is square root of mu times q. Right? That's all it is. So mu times q. Remember, q is simply, and you could rewrite this in a different way and say that it's the square root of mu times 1 minus p. Okay, it's the same thing, 1 minus p. Right? It's the same thing. It's the same thing. Q is just 1 minus p. So this is just these equations. Just remember them, use them. I'm not sure if you have a formula sheet or not. I'm guessing you might. And one thing as well, remember that standard deviation is just simply the variance squared. So if you want to find variance, it is equal to sigma squared. So all you have to do is square the standard deviation, all right? So it's equal to يعني doing your sigma like this, squaring it, all right? Whatever value you get for your standard deviation, you square it, you get your variance. Tamam? So this is just a formula. Apply. You know what your n is, you know what your p's are, and that's it. Okay? Now, normal distribution. Normal distribution, like I said, it's continuous and it has this shape. Okay? What you need to know about normal distribution is this is the normal shape of it, how this is called the bell curve, all right? And the distribution has a few important things. So the middle part here, the center, is called your mean. This is your mean mu, all right? This is the center of your normal distribution. And when you are going to the right or to the left, you have a specific distance that you are going, which is a distance of your standard deviation sigma. Okay? So this is each distance between these is sigma. And each of these represent a very specific percentage where it has been given, yani it has been already calculated. This is, I believe, 68.3%, if I'm not mistaken. And then it becomes 95% from here to here. And then, yani, if the curve is actually following it properly, and hello majara. All right. This isn't that important so far, but you guys should know what it means. What it means is, this normal distribution means if you have something within this range over here, when your x values is somewhere around here, it is a very small chance of it happening. When it's closer to your mean value, it has a higher chance of it happening. And then again, when it is much larger than your mean value, it has again a small chance of it happening. All right. So again, how do you find these lines? Since this is sigma in that direction, this is simply just going to be mu minus sigma. This is going to be mu minus 2 sigma. And this is going to be mu minus 3 sigma. Same thing on the right side, but in the right side we're adding, so this is going to be mu plus sigma and mu plus 2 sigma, and then 3 sigma, 4 sigma, and so on and so forth. Okay? This is your normal distribution. There's something called standardizing a normal distribution, because when you have a specific mu, it can be different for a lot of different things. Like you sometimes can have an average of 1 million, of 1,000, of 10, 7, 6.5. There's a lot of different possible values depending on the situation you have, the probabilities that you have, and all of that. So the numbers can vary a lot. So there's something called standardizing. Right? Standardization or standardizing something. What does this mean? We are going to do this exact same bell curve, but for a more simple, more straightforward values that are direct and easier to calculate, with the center being 0. All right. So it's going to look something like this. I believe I got a picture instead of me drawing a bad picture. Let me show you a proper picture. Yes. So this is what standardization means. All right. So again, as you can see on your left side, the left side is your normal distribution. All right. Your normal distribution here is usually written as x of a normal distribution, the letter n. All right. And then here you're going to have your mean. So this is your mean. And this is your standard deviation. Okay. This is how it's usually written for normal distribution. You have mean and standard deviation. Okay. When you are standardizing, you are basically using a formula so that if you notice on the right side now, this is a standard normal distribution. It has the exact same thing as the left side, like the exact same shape. However, if you notice now, our axis is no longer an x-axis. We call it the z-axis, where z is your standardized there was a name for it. It's basically your standard curve. Okay, this is the standard form of x. There was a name for it that I cannot remember. Yes, it's the standard score. Okay, z is basically your standard score. And to find your z, you just simply use this formula, which I will go through in a bit. But if you notice, the idea is your x-axis is the only thing that is changing. The probabilities are exactly the same thing. Remember, the probability is just the area under the graph. Okay, that is what the probability is, the area under this graph. If you look, the areas are exactly the same. The only difference is we have more standard values here of 0, 1, 2, and 3, rather than having a mean with mean plus standard deviation, because it will always change for each different scenario. So the most important thing you need to know here is that z is equal to x minus mu over sigma. All right, this is what our z is equal to. So it's equal to x minus mu over our standard deviation. Remember, again, mu is just our average, our mean, and sigma is our standard deviation. Okay, so now to find the normal distribution of this, okay, we will, or to find, sorry, the standard score of this, given any example, we will be given the mean and the standard deviation, or we might have to find it using the previous methods that we have seen. And then we can just simply find our standard normal distribution, and then we will use the graphs to determine what it is. Like I said, it's the area under the graph. In calculus, to find that, you usually do integration. But in your case, since you guys are not applying calculus, you're just going to refer to the table so you can find it out. But of course, there are methods of using the table, which we'll go through now. So first, let us look at an example so that we know how to apply this. All right. So here it says, give a normal distribution with mu is equal to 100. So mu is equal to 100. This is our mean, all right? And our standard deviation is equal to 10. So now that we have these two, we know that for any value of x, we can find the value z, which is your standard score of it, all right? Now, let us start solving this question. So, determine the probability of the following by transforming them into a standard normal variable, which we will be doing, and shading the area under the standard normal probability curve. So first things first, we have A is the probability of x greater than 75, all right? So this, we know we're going to get a probability of z, capital Z, greater than a specific number, which we need to find. This number is, we do z, small z, is equal to, what was the equation? It is x. What is our x value here? Oops, what is our x value here? This is our small x value, 75. So 75 minus, what is our mean? It is 100, divided by our standard deviation, which is 10. This will give us 75 minus 100 is negative 25 over 10. So it is equal to negative 2.5. This is our small z. So this is greater than negative 2.5 on a standard score. So remember, how do we find the probability of a normal distribution? We have a graph. All right. We have a graph and we have values over here. I'm going to try to my best draw it as neatly as I can. Then we're going to have the values. If you look at here, we have the values up to 3 usually. All right. It keeps on going forever, but as it approaches negative 3, khalas, the probability is so minimal, no one usually looks at those parts. So we have from negative 3 all the way to plus 3 looking this way. So we have something like this. This is 1, negative 1, negative 2, and then negative 3, something like that. The middle is 0. All right. This middle part is 0. And then again, on the right side, we have the same thing. We have 1, minus 1, plus 1. So it's going to be 2 plus 1. It's going to be 3. Okay. This is what it kind of looks like. So now what are we looking at? We're looking at a z value of greater than negative 2.5. So we're going to locate the z value. Where is negative 2.5? So this is minus 1. We go left, minus 2. Minus 2.5 is going to be somewhere here in the middle. All right, so this is minus 2.5. This line here is minus 2.5. Okay? And we are looking at the probability when this value of z is greater than this. When we're looking at greater, so greater, we're going into that direction. So we're going to the numbers that are bigger than negative 2.5. So negative 2, negative 1, 0, 1, 2, 3, these are all greater than. So the shaded area is going to be this area. Okay, this entire area over here. Okay, this entire area is our shaded area. Everything that is to the right of negative 2.5. So now how can we find this probability? Since we're not using integration, we're going to be using the tables. All right, so the tables are over here at the bottom. So we have two types of tables. Okay, and I will show you them actually just as this over here. All right, we're going to have two types of tables. We're going to have this table and we're going to have this table. Okay, so this table is basically, if you notice, the shaded area is only always to the left, not to the right. But in this case here, the probability is of z when it's less than. So in this case, we always have when it's less than z. So it's basically z less than a value a or a value small z. All right. This is the case that we have in our tables. So z is smaller than less than smaller z. All right. Why? Because we are going to a value that is smaller than z. of a value that is smaller than z. All right. In this case here, we don't have less than z. We have greater than z. We have the opposite of what we want. Okay. My method, there are some different methods that can be shown. I don't know how you guys were taught this in class, but I'll show you the method that I use usually to solve this, because it's a much easier method in my opinion, and it is much more direct using basic algebra. So the graphs, again, we are given a value when it is less than z. We can directly use the graphs in that case. But in this case, we have greater than. When we have greater than, we cannot use these graphs. So what am I going to do? I am going to flip this sign. So in algebra, if we have z is greater than negative 2.5, all right? You can simply just flip the sign and do this. Z is less than 2.5, all right? This is the first method you can do. So now we have a less than sign, and we will change the sign from negative to positive. This is one method, okay? I will show you the other method as well. This is one method you can use, okay? So we always have to have a less than to be able to use the graph no matter what. So this is the first method you can use. You can find the probability now of this, of z is less than 2.5. Obviously, the graph is going to look differently now, and you will see how. So let me just move these two a bit less down. So if I copy paste this graph down here, okay, now we are dealing with this, the probability of, z is less than 2.5. So we're no longer dealing with all of this over here. Now we are dealing with less than. So we're not looking at these numbers anymore. We're looking at positive 2.5, which is going to be over here. Okay, so this is our 2.5. And we are looking at less than. Less than means we're going in that direction. So this is now our shaded area over here, up to 2.5. Okay, this is all our shaded area. If you notice, it is exactly the same as the above one, because remember, this is a symmetrical curve. What does that mean? معناته الصوب اليسار يساوي الصوب اليمين in the shape. If you notice the shape هني, اليسار يساوي اليمين. There's symmetry, meaning the left side of this center line is equal to the right side of that center line. So if you notice, it is the exact same graph, but we are looking in the opposite direction now. But it's the exact same size. And now, for this case, we can look at our probabilities. So we have two graphs. We have this and this. What does this graph look like? It looks like the right graph. So we're going to be using our right side, probability curve tables, I mean. So we're going to go to that table and bring it up here, which is this table. I'm going to bring it here. Okay. So this is the table we have. Let me show you how this table is used. So again, the reason I'm drawing this is so I can show you what it will actually look like on the normal thing. When you want to just find the probability, if they're only asking for probability, as soon as you find z and you do the flip, you have a less than, you can straightforward just directly go to your table. If it's positive, the value, you're going to go to this table. If it's negative, you're going to go to this table. All right. So again, here, this is z is negative. And here, the small z is positive. Okay, that's the only difference. So the left graph is used for when z is negative, and the right graph is used for when z is positive. So z positive. All right, that is the only difference. Now, what was our probability? This is the probability we are trying to find. Remember that this probability is equal to the probability above. All right, these are the same probabilities. يعني the equation z is greater than or equal to minus 2.5, this is equivalent of saying z is less than 2.5. These are equal things. They are not different than each other, because what did we do? We did algebra over here. We did algebra to change this. All right. We basically swapped the sign and changed the swapped يعني the symbol and changed the sign from negative to positive. This is one method I like using. All right, I haven't seen this in the notes, but this is the method I like to use when I basically want to apply when I'm trying to solve inequalities. So going to how to use the table now. Again, this is the probability we're trying to find now, which is of z less than 2.5. So I'm going to just bring this down here. So our z value is 2.5, right? This is the value we're looking for. We're looking for 2.5. So we're just going to look to the left for 2.5. This is 2.5, all right? So we know the value is going to be in this line over here, all right? The value is going to be somewhere in this line, okay? But what is these 0.00, 0.01, 0.02? This is just decimal points. What does this mean? هني عندنا we have 2.5 which is basically 2.50 نفس الشيء زين. So these, the top row is basically just this zero. فهني because 2.5 it's 2.50, we are going to be looking at the first row. زين. So because of this, we're going to be choosing the first value, which is 0.9938. So the probability of z greater than 2.5, which is equal to the minus 2.5, which is equal to the probability of z less than positive 2.5, is going to be equal to 0.9938. Okay? Try to understand what I have done. Okay, we'll just take a 2-minute break. Okay, I need to make a phone call. Someone's calling me and I really need to answer. We'll take a 2 to 3 minute break. Understand what I have done here. Try to solve it yourself. I'll come back and we'll solve more problems. Don't worry. Okay. The idea again is, I'm just going to cover it very quickly. When you have greater than, you cannot use the tables. So you have to flip the sign and make it less than, and I will show you the other technique you can do as well. So you flip the sign and remove the negative or add a negative. So the sign here will change. Since this was already negative, this will become positive. If this was positive, this will become negative. Okay, that's what you will do. And now that you have less than, you just look at the value up in the table, and then wherever the value is, you will take the value, and that will be your probability in the curve. All right. So 2 minutes, I will be back. Just need to make this phone call and we'll solve more problems. If you have any questions, feel free to type them now in the chat until I'm back, so I can look over the concepts that I should do again. Okay. So let's see. Do I have to flip? What do you mean by flipping? Flipping this? Yes. If you have, again, if you have greater than, you're going to have to do a flip. This is just one way of doing it. If we have a negative number, we should transform it to positive? Yes. يعني هني if we have a negative number it will become positive. If we had a positive number it will become negative. Okay, so in the given when we found it as a negative number. Okay, when we did our standardization. Then when we found our z, it was negative. We don't care about this. We care about this, the greater than or less than. If it's greater than, we cannot use the tables. So we have to change it to less than so we can use the tables. And one way of doing it is by flipping the sign and flipping, then you can flip the actual inequality. All right? That is the way to do it. The other method of solving this, okay, the other method of solving this, all right, again, we reached to this point. We found P of X is greater than minus 2.5. I'm pretty sure all of you know how we reach this. This is just the very first step. And then, which is basically this graph. Okay? It is just this graph. So I'm just going to make this a bit smaller and keep it on the side. The other way of doing this is, remember what we learned early on? Remember when I said we're going to use this again? So remember when I said P of A is equal to 1 minus P of A inverse, or not A, okay? This is the proper method of how you are supposed to do this, which is P of Z greater than minus 2.5 is going to be 1 minus P of Z less than or equal to minus 2.5. In normal distribution, the equal sign does not matter much, okay? Because we are shading the entire area. We're looking at areas. We're not looking at specific numbers. This isn't discrete anymore, so it is not this, so it doesn't matter if it's less than equal to. And you could put this just as less than, and it is just the same thing, all right? In this specific examples, yani. So this is the way you will do it. So if you notice, what did we do? We found the not A. Remember what I told you, Z greater than negative 2.5. The not greater than 2.5 is basically less than or equal to negative 2.5, all right? It's still negative, but now we have a less than sign. But remember, we also have a 1 minus, okay? What this will look at like in this graph, all right? If we just take the same graph again, it is basically saying, that this is the graph, right? This is the graph that we have. So now if we want to plot this part, okay, we're plotting this part. So we're not going to look at this anymore. We still are looking at the negative 2.5. Okay, we're still looking at the negative 2.5, but now we are looking at the less part. The lesser part is basically here. This is the lesser part, right? Remember, this is a probability curve. So معناتها this entire graph, the area of the entire graph is going to be equal to 1. It's equal to 1. The full area of everything has to be equal to 1. Okay? So in other words, what are we saying? We are saying we want the value of not this. What's the value of not this? It is basically the entire remaining shaded area, which is here. Right? This is what this means. The same thing can be said. So this was our original graph, the red part. صح ولا لا? This was the original part, the red part. We used to say that this is what we're looking for, right? So we can find it by saying we want not the other part, or 1 minus the other part, because this is the remaining part. This is the whole point, the whole concept of using 1 not, okay? So now what we are doing is we are using this graph to find the not part, because the not part is less than. So less than is going in that way. So it's the not part of negative 2.5. We're going to use that table to find this not part, not this table, the other table now. We're going to use it to find the not part. And then we're going to do 1 minus to find the actual answer of what we want. So how would that look like? So instead of using this table, now we're dealing with a negative number. We're going to be using this table. Okay, so we're using this table now instead. So again, what's the probability? It's Z less than minus 2.5. All right, so minus 2.5 is the number we're looking at. So we go to minus 2.5. which is here on this line. This is minus 2.5. Again, all the top part is, all it is the second decimal. So this is minus 2.50, minus 2.50. So it basically means it's 0.00. All right. So we're going to take this value, which is 0.0062. So now if we substitute this back in, so P of Z greater than minus 2.5 is equal to 1 minus this value over here, which is 0.062. And we're going to notice that we get this to be equal to the same value we found early on, which is 0.938. All right, so these are the two different ways you can solve them. Both of them are completely correct. You can use both to solve either case, all right? But it depends on what you are more comfortable with to choose. So I want to know from you guys, which one do you guys feel is easier? When you're finding the conjugate or the opposite of this, the not part, or if you're just solving this where you're doing basic algebra and just flipping the signs. What do you guys think is easier, this or that? I want to know, يعني, in general, what you guys are finding easier, so I know which method I should use for solving. Wow, شو راقدين مو فاهمين? Are you guys understanding? Can you please type something in chat if you're understanding? فاهمين النقطة? If you're not understanding, tell me. But if you're understanding, please tell me you're understanding. عشان I know that I'm not just talking to myself and just wasting your time with mine, unfortunately. I want you guys to understand, عشان inshallah in the exam tomorrow, you guys are just going to ace this part. Then this is the easiest part. Like normal distribution is very easy. All right? It's very straightforward. Okay. Zain. Good. At least some of you are getting this concept, which is good. And we're going to do a few more questions so you guys know how this is going to look like. All right. Again, the same question, but now x is less than 112. All right. I'm going to try to solve this entire question and conclude with that. So now again, we have P of x. Was it less than or greater than? I forgot. Less than 112. All right. So P of x less than 112. Remember, we already have our mu is equal to 100 given in the question and our standard deviation, which is equal to 10. Do not forget this. Do not forget how to basically find your z value first. That's the most important thing. If you can't find your z, you cannot solve anything else. Okay? So, 1 second. Okay. So you're going to take mu, again, we are finding z first. That is our very first step. We're finding small z. Our small z is equal to x, which is 112, minus mu, which is 100, over 10, which is our sigma, which is equal to 12 over 10, which is 1.2. This is our standardized form, all right? So now we can say that P of Z is less than 1.2, okay? Now, again, without drawing the graph, you should be able to recognize this. This is already less than. So instantly, what am I going to do? I'm just going to go, since it's a positive number, I'm going to use this table. All right, go bring that table and just bring it here without looking at the graph at all. We don't even need to look at the graph. We know it's going to look something like this anyways, because it's a positive value and less than. So it's less than 1.2. We go to 1.2. All right, we go to 1.2. And since there's no decimal points after it, it's 1.20. So it's 0.